All right, now we're going to talk about lesson 11.5, and we're going to be talking about today how to multiply and divide radicals. So how do I multiply and divide radicals? So let's go over a couple basic things first. First of all, we have what we call the product law for square roots. That says if a is greater than 0 and b is greater than or equal to 0, that means that both the numbers have to be either 0 or bigger. They have to be whole numbers, which means they cannot be negatives. Then, if I multiply the two square roots, I can rewrite that as just one square root with the numbers being multiplied inside. So, an example, the square root of 2 times the square root of 3, I can rewrite that as the square root of 6. So I can just multiply 2 by 3 and put those inside. The square root of 2 times the square root of 2 is going to be the square root of 4, which we know is 2. And that shows us something that's really important for this lesson. Anytime I multiply a square root by itself, it just equals that number. That's really important for this lesson. So, let's look up here. If I have the square root of 900, you probably don't know what the square root of 900 is, but you do know what the square root of 9 and the square root of 100 is. So just like I can do the square root of 2 times the square root of 3 equals the square root of 6, I can do that in reverse. The square root of 6 is the same as the square root of 2 times the square root of 3. So the square root of 900 is the same thing as the square root of 9 times the square root of 100. The square root of 9 is 3. The square root of 100 is 10. And then I want to multiply those two together. So the square root of 900 is 30. And I can test that by doing 30 by 30 and I will get 900. The square root of 48. Now we know there isn't a square root of 48. But the square root of 16 times the square root of 3 equals 48 because 16 times 3 equals 48. And I know that the square root of 16 does have a square root. So what I have is 4, and then since this 3 does not have a square root, I leave it as 4 square root of 3. Don't put a plus between there or a minus because they're being multiplied, so they should be next to each other like that. Now, how about if I have a bigger number and I don't want to have to think about, which factors have a square root? Well, the best way to do it is start off by doing the prime factorization for that number. Step 2, every time you have two of the same, remember anytime I have two of the same square roots, that's going to equal that number without a square root. So I can pull one out, and then anything I have left inside I can multiply, anything I have left outside I can multiply. So, square root of 162. I did the prime factorization here. Again, make sure you know how to do prime factorization. And now I rewrote the square root of 162 as all of the factors. Now notice the square root of 3 times the square root of 3 is the square root of 9, and that's just 3. Again, square root of 3 times the square root of 3 is 9, which is just 3. And then I have the square root of 2 left. So I have 3 and 3, so those are both without square roots, so I'm going to multiply those together. All of these are being multiplied. So this is going to be 9. 3 times 3 is 9. And then I have the square root of 2. Always put the square root at the end. 675, same thing. I'm going to do prime factorization. I'm going to rewrite all of my prime factors as square roots. Every 2 is going to equal that number without the square root. That's 9. Square root of 9 is 3. 25, square root of 25 is 5. And then I have the square root of 3. So the numbers without the square roots, I'm going to multiply together. And then the numbers with the square roots, I'm going to multiply. There's only one, so I leave it like that. And that is my answer. Now, how about if I'm, instead of having one big number that I have to break up into small numbers, what if I'm multiplying radicals? So let me show you an example of this. Get rid of this here. And let's look at another example of when we're multiplying radicals. So let's say, for example, I have the square root of 7 times the square root of 3. So square root of 7 times the square root of 3. Well, remember, for my product rule, all I have to do is multiply the inside number. 7 times 3 is 21. So that's my answer, the square root of 21. That doesn't have a square root, so I just leave it as the square root of 21. How about the square root of 14 and the square root of 21? Now for this one, these were both prime numbers, so I just multiplied them together. Excuse me. These are not prime numbers. So if they're not prime numbers, what I'm going to do is even before I multiply them, I'm just going to do the prime factorization for all of them and write it out as all prime factors. 14 is 2, 7. 21 is 3, 7. So now I wrote it out as all square roots of the prime numbers all together. Now, any that are 2 that are the same, that's going to be the square root of 49, which is 7. These are not the same, so I'm just going to multiply them together and leave it inside the square root. So my answer is 7 square root of 6. So I rewrite them all as prime factors. Any 2 that is now without a square root. Anything that has square roots that I don't have 2 of, I multiply together and leave it inside. Let's look at another example. 2 square root of 54 times 3 square root of 15. Now notice with this one, I have numbers outside and inside. So what I'm going to do is I'm going to multiply my outside numbers, 2 and 3. Then my inside numbers, since they are both not prime, I'm going to do the prime factorization for both of those. So 54, it's going to be 2, 27, 3, 9, 3, and 3. And I'm going to rewrite those. So square root of 3, square root of 3, square root of 3, square root of 2, square root of 3 for 15, and square root of 5. So for the square roots, I wrote out all the prime factors in square roots. For the numbers that are not, I just multiplied those together and left them on the side. Now, remember every 2, that's going to give me that number outside. So I have 2 square root of 3, that's square root of 9, which is 3. Another 2 square root of 3, that's the square root of 9, which is another 3. And then neither one of these have other ones, so I'm going to multiply those together and leave them inside. Now notice I pulled both of these out. So now I have 3 numbers outside. So I want to multiply all of those together. 9 times 6 is 54 square root of 10. So you multiply any numbers that stay inside, multiply those together. Any numbers that get out, multiply those together. And then that gives your answer of 54 square root of 10. Now, last part that I want to talk about is how to divide square roots. So how do we divide square roots? Well, dividing square roots is very simple. There's just a couple steps. The first thing you want to do is check. So if I'm dividing, first step is check if top and bottom have square roots. If they do, then just find the square root of the top, find the square root of the bottom. If you can divide, divide, otherwise just reduce. So let me give you an example of that. If I have the square root of 25 over 4. Now, just like if I have this, I can write it as the square root of 2 times the square root of 3 or the square root of 6. The same thing, if the square root's over the whole thing, I can either write it as the square root of the whole thing, or I can rewrite that as the square root of 25 over the square root of 4. So you can write these either way. These mean the same thing. What is the square root of 25? That's 5. The square root of 4 is 2. I can't divide that, so if you can't divide it and you can't reduce it, you don't have to write it as a decimal. Just leave it as an improper fraction. So if both the top and the bottom, both 25 and 4 have square roots, then I do the square root of both and then just leave it as a fraction. What about if they don't both have square roots? Well, if they don't both have square roots, then check to see if they can be divided. And then find the square root. Okay, so let me give you an example of this. Let's say I have the square root of 45 over the square root of 5. Well, I know the square root of 5, that doesn't have a square root. Square root of 36 is 6. Square root of 49 is 7. That doesn't. Square root of 5 doesn't. You have 4, you have 9, but not 5. So I'm going to rewrite this as one big one. 45 divided by 5 is 9. Does 9 have a square root? Yes. So I divided the two numbers. They're still inside the square root. And then I find the square root of the answer. Sometimes one of them will have square root, but not both. If just one of them has square roots, divide. Don't find the square root of the one. Divide and then find the square root of the answer. So for example, if I have the square root of 18 over the square root of 9, so I know that 9 is 3. So you might want to do this. The square root of 18 over 3. Don't. That's wrong. Don't do that. If both of them have square roots, then yes, find the square root of the top and the square root of the bottom. But if only one has a square root, don't find the square root of that one. Instead, divide the numbers. So write it as one big one. 18 divided by 9 is 2. Does 2 have a square root? No. So I'm just going to leave it as the square root of 2. So if both have square roots, find the square root of the top, square root of the bottom, and then reduce or divide or leave it as an improper fraction if you can't. If only one or neither one has square roots, then divide the top by the bottom and find the square root of the answer. It's that easy.